You will have noticed I am not Matt. Well, I hope you've noticed I'm not Matt. So let's welcome you back to the final session. We are switching up Slido a little bit for this session. So we are still using Slido. We still encourage you to use Slido. But if you're in the room and you are happy doing so, we'd like you to put your name on the question and then we can open up into a dialogue with those on the panel. Okay? So welcome to the session on preparing the next generation of research computing infrastructure. And I'm going to ask the panel from the far end to this end to introduce themselves and their roles, so you haven't forgotten this time.
Hi, I'm David Baldwin. I'm from the University of Leeds, and I'm the Director of Digital Research.
So, hi everyone, I'm Manhui Wang from the University of Liverpool. So, I'm the head of research IT platform. So, we manage the HPC cluster and provide research computing service for the university.
Michael Holliday, I work in University College London, and I work in the research infrastructure team looking after all of our clusters, storage, and anything else in our data center.
There we go. I'm Martin Callahan. I saw you all this morning. I'm a consultant at Red Oak Consulting. We work with lots of organisations across the public and private sector on all things research, computing and digital infrastructures. And I'm an ex and reformed academic. I'm back again to say hello to you people.
Okay, so in true style, I'm not asking the questions in quite the order they're written. So one question I'm going to start with is, what does the future of research computing infrastructure look like at your institution?
Yeah, I can answer first, and because we are just preparing for the HPC upgrade, and so what we think about is the HPC should be suited for your need, and so either it's data intensive or CPU intensive, and either you need your AI and machine learning power or something like that, and also we need to move from the traditional HPC area and to attract more less representative area like human and the social science. So that require us provide like user-friendly interface, and also for us itself, we need to just prepare for the skilled workforce. And so we can provide the training, especially for the research without any technical detail, technical knowledge. So that's also meet the requirement for the research group. And so they have some, like every year they might be apply for some research funding for the hardware, also for the revenue maintenance. And so in the central IT, we try to just meet the requirement, how they can just efficiently just use the funding to support, to make the cake larger. And so basically we like to build like central based HPC infrastructure, then allow the research group to add their own dedicated node. We have the mechanism to prioritize such dedicated queues, and for this research group who provides funding for the dedicated node. Yeah, that's also a lot of things like for the next generation research computing facility. So one of the things definitely is the energy. So how we can just provide like energy efficient solutions. This is not only just when you design your HPC cluster, but also in terms of skilled workforce. So how we can just guide the user, use the HPC properly. That's one area most HPC center might be ignore that, and because they think, oh, this HPC class is good and so it's very energy efficient, but they might not care about user how to use it. And just for one example, and in one of our Tier 2 centers, and so it's GPU cluster, and at one time, all the jobs are just use CPU, and so that's cause a lot of issues. This is how we need a skilled workforce, how to develop some simple tools to detect whether the CPU is used for this, for whether the GPU is used for the GPU node, whether this CPU node is used and with right memory or something like that. And some of them, like the traditional sequential code, and if you request like 100 and 200 CPU cores and across multiple nodes, it won't work. And so that's a little bit challenging. So basically, what we think, we can just do a little bit things, but make a big change.
Yeah, so we're going to get into challenges and things in a little while. Yeah. So, Michael, what do you see as the future of research computing infrastructure?
So certainly at ECL, we have a wide variety of departments. They're all asking for anything and everything, be that AI, be that inevitably GPUs in every 5 seconds. But we also have huge amounts of data. We have huge amounts of sensitive data. So what we're looking at is trying to still provide our traditional HPC systems, but also provide flexible computing. So we have a private cloud system that is being developed and is almost in service, but that's giving users the flexibility to actually spin up their own VMs, containers, anything else they need, running their own services within reason, providing standardized services like RStudio and other things on top of our systems, and also then providing them the support along with our RSE colleagues and everything else to actually then let them run their AI systems and anything else that they're looking at, and trying to do that in a sensible way, but then also encouraging them to put the data in the right place, and so we can then provide it in the best possible way and then manage that through its entire life cycle.
Thank you. And David, are things looking different or similar at Leeds?
So we are doing quite a lot of work on the infrastructure at the moment. So we've just purchased a new HPC cluster, which goes live in about 2 weeks. We have 2 more planned, one for later in 2025 and one in 26-27. So there's quite a lot of work going on, sort of more traditional HPC, just building clusters. These are replacing some quite old machines. We had a 9-year-old machine we've just taken out. It's not all about HPC, of course. We're doing a lot of work around storage, things like DRIs and all that needs to be set up. We don't really have an archive, so that needs a bit of work, and really the sort of data management flow. And then probably the most complicated bit is there's no real service in the university at the moment for containerization or for VMs. So everybody, of course, just buys a desktop and sticks it under their desk, and then it has very low utilization and eats all the university's electricity and all that sort of stuff. So trying to build almost a brand new service. To most people, I'm sure this is very basic, but just trying to build some sort of containerized or VM service so people can kind of buy into that. My main problem, of course, is money. So we have some money, luckily, but we need to make sure that we spend it wisely. So.
Yeah, we know a lot about those machines under desk. We share an office with CS, one of their research groups, and we just walk around the office and there's these machines wearing away with various GPU cards in them all the time. We literally sit around the corner.
Yeah, and the previous session, of course, was about security and all these machines. We know where most of them are, but not all of them. So, and some are patched and some are not. And so there's part of it is utilization and carbon footprint and these sorts of things. And some of it is simply we would rather have not have unpatched machines on our network. That just doesn't make a lot of sense for us. So.
Yeah. So Martin, obviously it's quite different from your perspective.
So I will offer a slightly different perspective and perhaps give you a little bit of an idea about what's going on elsewhere in the sector. Certain type of institutions represented this week, which is great, but what is represented here today is a relatively small part of the sort of research and education, the HE ecosystem in the UK. We've done a lot of work recently with some non-Russell Group universities, the traditionally non-research intensive universities, and I think possibly something to be aware of is that they're after your research funding, and they are prepared to think and work in more agile ways than perhaps you would like. And obviously there's lots of discussion here about infrastructure, about HPC, but some of these newer players regard as very, very legacy perspectives. And they think that they can work faster and more agile than you and attract research funding to their research groups who, I have to say, are just as good as your research groups, but traditionally haven't been able to attract that type of research funding. Strategically, they have different priorities, but very many of the non-Russell Group want to be more research intensive and are actively prioritising that strategically at a very high level. And like I say, as a consequence, they're looking at DRIs from a completely different angle. They're prepared to think less about infrastructure and more about the research in terms of workflows and choosing the right platform, whether that be a cloud platform or a private cloud platform, to talk about technologies like containerization and Kubernetes, which of course to normal HPC people is a difficult conversation to have. Well, they're prepared to think about this. And they're prepared to look at solving their problems in new and different ways. It'll be interesting to see how that develops over the course of the next few years, but I think that's something that perhaps this group of people just needs to keep a little bit of an eye on. I would say as well that there is clearly lots of interest in AI, but as we've heard in a number of panels today, I think at the moment there's no real understanding of what this is and of what the implications are likely to be in the future. We've had this announcement earlier on in the week, and some of us were talking at break time that we think that most of the money is likely to go to 4 big players in London, whereas if that money was spread up around the country, it could probably do an awful lot more damage in more interesting ways. And I think the final point as well is probably more important than any investment in infrastructure is investment in people and training and sustainable careers. And it's been great hearing that is what a lot of people in this room believe in, but there are yet lots of people in your institutions who don't and perhaps need to be persuaded that this is a good use of time and energy and money.
So this kind of leads into my next question. Actually, I think it's a really good one for David because you're building a service from scratch, effectively. So how can we ensure that the next generation of our users, or for them, or our next generation of what we're building your service, is accessible and inclusive to all the researchers from various disciplines and backgrounds?
Yeah, I mean, of course, most of our HPC users are the STEM faculties, so engineering, environment, and medicine. Definitely our biggest sort of users by flops. We have seen quite a lot of other faculties become very interested. So the business school is interested. The machine we're just putting online now, we have 5 intensive users doing the UAT for us at the moment. One of those is actually from the School of English, so he looks at languages. Okay, large language models, AI, why wouldn't it be in the School of English? I mean, it almost makes sense. He's pretty much a lone wolf in the Faculty of Arts, but he's there. So we're trying to leverage a lot of that. Social sciences, very interested in taking all those horrible, nasty spreadsheets they have and trying to turn it into something a little bit more compute intensive. And some of that is also around the TREs, so looking at criminal data rather than necessarily medicine. So they want to be able to use some of the facilities we're building as well. So I wouldn't say any of the non-STEM faculties are using a lot, but they are very interested. And we do outreach to, we had one recently in the library and for the arts faculty, and that was quite well attended. People are very interested. I think a lot of it is they don't know the question to ask us yet, so I think a lot of it is on us to go and tell them the sorts of questions they could ask us, and then that might be interesting to them as well.
So is some of that also part of, and this is completely off piece, not on your question sheet, around how we market our services, but also the interface to those services to our departments?
Yeah, definitely there's a lot of work you have to do. I mean, there are 35 schools at the University of Leeds, and I think I have to visit each one individually and talk to every single professor individually, but that's okay. That's, part of my job. One of the ways we're trying to do it is sort of a doctoral college where all the PhDs start, trying to sort of get in there early. And if you do it across the whole doctoral college rather than just for faculty, then hopefully you try and reach some of these, younger PhD students who have different ways of thinking. We've talked a lot in these sessions about, how they interact with computing in quite a different way. So if you can kind of present them some of the solutions, they may actually think up more interesting things than we could think up. And then try and get some of these non-STEM sort of PhDs to actually use the facility. It's free and they pay for it, so why wouldn't they want to use it? So,
Michael, Unified AI platform.
Yes, so we have, in many of our ECL, we have another Unified AI platform. It has been going for, I'm going to say at least 2 years. It's been in existence. It's sort of in production. We have a whole bunch of people testing it. It has not been without its challenges for various reasons, like footballs and an ever-evolving what exactly was it meant to do in the first place is not what they want it to do now. So we are constantly trying to evolve that system. We are currently trying to amalgamate it into our private cloud system so that we can actually reuse the GPUs and rebuild the infrastructure on the fly in a much easier way. But we're also then trying to find ways of giving people access to it through GUIs, through the command line, spinning things up, working with various layers of services and software so that people can use it as easily as possible, but while trying to keep it being used as efficiently as possible, which is usually our main issue with our GPU systems.
Yeah, so the audience for this wasn't the STEM disciplines as such that drove that.
Not originally. I can't actually remember who it was that actually started that project. It has been handed through to so many people at this point. But yeah, it's very much a generic platform that is designed for everyone to use. So we have various users from different departments. A lot of biomedical departments, yes, do use it, but we do have all the various humanities are looking at how they can make more use of it. We have a bunch of test users currently trying to figure out what the best thing to do with it at the moment.
Does anyone else like to think about how we make this inclusive and accessible?
Yeah, I think the most important thing for this is for the less representative researchers, and they don't have the necessary skill and knowledge, and so the training and so is the key. And so in the local level, at the local level, so we while we approaching the researchers and persuade to use the HPC facility or other research computing facility, so how we can engage with them, provide necessary so training, and that's important. And so so also another part is for a new user from this department, like humanity and social science, and so when the first just touch HPC, how can you treat like other experienced user from computation chemistry or something like that? Or we definitely need to pay more attention to these new users and so guide them to learn the necessary skill. And so even the document is same, but the people from this other non-traditional HPC area might spend a little bit more time, and so might require us to provide more support into this. And also just in the like job scheduling or other the environment designs, how we can just consider just users with less experience, and how we can just make sure. And so other users might be quite, it's very easy to understand for other users, and so they need to submit the job to the queue. They maybe wait a couple hours to get job running, but for the user, like from the humanity or other department, they maybe don't understand why I submit job, I haven't get the resource. So you might just still set up like the policy, and so for because there are maybe just 1 or 2 users from the whole department, and in the very beginning, they might be get very high priority, and so in the very beginning, they might be see the job running very quickly, and so just get the resource, and so provide just a very user-friendly experience for them. Yeah.
Thank you. Martin?
I will. I'll pick up a couple of points that people have already mentioned. I think for me, one of the most important factors is to have people in your DRI teams who are prepared to engage with all of these potential new areas and new customers, and to understand and own their problems. And for those of us who come from perhaps a classical sort of infrastructure background, or perhaps a STEM background, talking to people from the digital humanities or life sciences or business schools, they're very different people who think about the world and have research problems that are very, very different. But if all of these new investments in research infrastructures are going to bear fruit, then it is going to need some effort from those DRI professionals to perhaps change the way that they look at the world, that they communicate with people. And perhaps there might need to be, in some quarters, and perhaps an opportunity for managers here to think about how soft skills are developed in their team, and how you equip your teams with the skills to better communicate with those new areas. And a sort of hint from consultancy here is that you often don't get to pick and choose the customers and the industries that you work with, but very quickly you're expected to be up to speed with the issues with that industry or the issues with that particular research domain, and to be very quickly respected in that area. And that's a huge challenge. And whether you're talking to people in industry, an industry that you've never worked with, or a research domain that you never worked with, to be able to get up to speed quickly and to gain the confidence of that new customer, I think is a really key and critical skill. And I think just about everyone else has mentioned it, so I'll mention it as well. It is about training, and that's equipping your users with the right skill set and the right mindset to be able to make use of these new technologies. But I'd probably also say a little bit as well is, and I wonder whether this is done effectively in those doctoral training programs, whether PhD students and postdocs particularly are being equipped with the correct sort of, let's call it an entrepreneurial mindset. Most of them are going to have to go out into industry at some point, and most of them are going to have to earn their keep. And, certainly my experience in Russell Group universities is that was very, very mixed. Equipping people with the ability to market their skills and to solve real industry problems with those skills. It's a bit of a hobby horse. I'll get off that now. Thank you.
Okay, I'm going to encourage you again to please put questions in Slido, because I have one thorny question remaining for the panel.
Dun, dun, dun.
So, and this for some of you is, we'll get to those in a second, because this is the nub of it, I think, and think of what we've been discussing on today is, so what are the key technological and organisational challenges and opportunities for the future of research compute infrastructure, and how can we prepare our institutions to meet these challenges?
So I wrote down a few thoughts here, and some of them are quite boring. So things like plumbing and electricity and stuff like that. I spend a lot of time talking to estates because we want to, use a lot of, give them a whole load of hot water. These are fairly easily fixed. So some of the institutional things are, how do you balance costs? So we have a limited amount of money, so why would you invest it in HPC or in research computing or research IT or whatever you want? Institutionally, like everyone else, we have a sort of discussion going on around Scope 2, Scope 3 carbon emissions. How do we balance those and how do we get that right? We have net zero goals, like I'm sure everybody else does, and so again, you spend quite a bit of time just sort of trying to work institutionally about how do we get that balance right for the institution. I think, Michael, you were talking about ease of use, and one of the sort of institutional things is how do you make it so that it's complicated enough that it's useful to researchers, but easy enough that they can actually use it, and then get those people, like we've just discussed, how do you actually then get the people to come and use it? So I would also say, having moved from industry, everything goes really slowly in the university. So sometimes it's just trying to work out how to push the right buttons to get things moving. If anybody knows the answer to that, I'd love to hear that one. So.
Michael, I'm going to pick on you because you're very much at the coal face of a lot of this.
So yeah, certainly I find myself stuck very much between various rocks. So we have various levels of management who want a huge amount of process to justify every penny that they give us, balancing that out against how fast we can actually physically get a system into a rack and configure it, and trying to justify all the staff and lack of staff at times. Just trying to balance all those things out, and then trying to explain why the thing that they wanted running 6 months ago is still not running, because we are then having to try and find political ways to explain that there are other issues outside of our own team, trying to sort out different problems, trying to explain that there needs to be other money to put somewhere else to try and fix a different problem. But then we're also dealing with the political issues, particularly UCL being quite as big and spread out as it is. We have a lot of politics, and a lot of departments, and a lot of people who would rather run their own system. So we're often trying to justify our own systems against other people's, even within our own computer science colleagues, trying to justify whose system is actually the one that should still be in existence, or whether they should both exist, or where the money gets split up and how it gets split up.
Thank you.
Yeah, so I definitely have a lot of feeling about this challenge. So in terms of your technology challenges, so basically as HPC teams, we do need to make sure, and so we adopt the right technology, and so in terms of hardware, and so whether your HPC can just support AI research or something like that, and that's the key point, because HPC and AI and just integrate together, and so we make sure this should just accommodate the emerging research like AI deep learning, large language models, something like that. Also some others like cloud platform and on-premises, and how can you just operate this system and so consistent and so seamlessly. And so that's one other challenge. And another is how we can deal with massive data and intent and versus data and privacy and security and the issue. And just one of them. So in terms of institutional challenge, and so basically in our research IT platform team, we try to just bring user with most advanced technology and the most maybe more computing power. But for the traditional IT service, and they might not think like so, and so this always battle just between the research IT and the central IT service. So how to balance that, while we can just make the best use of the research, the network team and the security team to make our system secure and have a faster network connection. And also we might just challenge some of the decision might be, because you're in the research computing area, we encourage innovation and creative, and so, but the traditional IT service might not think so. So other things, and I still think your skilled workforce, and so it's very challenging, and so with more people just move from the university to industrial, and that means university may be lack of the skilled people to manage it, to provide the necessary service to our researchers. And so, yeah, so this is what I think about the challenges. Yeah.
Cool. Martin, any thoughts?
Yeah, so I'll probably concentrate more, I think, on the sort of organisational strategy side of this. And I think, as a few people have already mentioned, that I think your biggest challenge at the moment, and certainly for the next few years, is to be able to cope in a world where funding is restricted. There is funding about, but particularly UK government funders are targeting that funding in particular strategic directions, and perhaps a world that existed, well, maybe it never did exist, but that was a little bit easier 15 or 20 years ago, I think is likely to get tougher in the course of this next Parliament. So that's the sort of the bad news side of it. But I think the flip side of that, and there is a positive here, is that this does actually give you an opportunity. It's not all doom and gloom. And I think it does give you an opportunity to think about how to solve problems in new and imaginative ways. It's certainly what the non-Russell Group universities are having to do. They've never had the research funding the research-intensive universities had, and yet they are still, in some areas, showing that they're able to compete on an equal footing. So it can be done. And perhaps together with that, universities need to think an awful lot more about how to exploit the intellectual property that is created as a consequence of research. And I think uniformly in the UK, it's not done very well. Some universities do this pretty well. Other universities pay lip service to it. And I do wonder whether there is huge untapped potential living in the intellectual property of research groups up and down the country. I sort of allied to that in terms of opportunities, you know, we see with collaborations like NHCIR, that there definitely are opportunities to share costs and share infrastructure, and perhaps that's something that can be explored a little bit more. And as these new tools and services, thinking about some of the things that Dave and some of the others have talked about today, is looking at how you can smooth the path to adoption. Because, of course, once you have developed these, I'm going to use this word delightful, I wrote that word down, I like the word delightful. Once you've developed these delightful new services, you want to think about how you smooth the path to adoption. And that's not just about training, it's about having the infrastructure and the mindsets within your research infrastructure teams to actually take people on that journey with you.
Thank you. So we're going to move to some of the Slido questions. And I do and I don't love AI. So it's what like my master's degree was in, but also at the moment, it's just driven me mad for 3 years because that seems to be the only thing people can talk about. So I really like this question. And I'd also quite like a bit of discussion from the floor on this about what we think the most exciting non-AI. And I'm going to include every variant of AI in there I can possibly think of. Especially not transformers. We're definitely not going down the transformer route. Piece of tech or digital research infrastructure on the horizon. So what is cool and interesting and exciting that doesn't involve transformer models? It can include machine learning, but you know, there's bits of machine learning I'm really not keen on at present. Anything cool and interesting? I think Steve's got his hand up. So internally, we've been playing with an analog computer. That's been fun.
Yeah. So some of the, just as I've left the computing department at Lancaster, one of the really cool projects that's coming in is FPGAs and building that into some of the cluster compute. And the logic being about looking at very low-level technology. So where in some of the machine learning research, there's some very core maths to it, trying to program that on very low-level CPU architectures and building that into HPC is a really exciting thing coming down the pipe that I'm sort of looking at and going, oh, it's going to be my job to support that. Great. But the challenges it presents are really cool, and I love the maths of it that's coming in. So I'm just really excited for it. But that's my own nerdiness coming through as well. So,
Yeah, so I'm going to pick on Sarah, who's behind you, because she had a question about skills, and the FPGA things came up a bit as a skills lack when we were both at UCL at the same time. So, Sarah, what is your question about skills?
Yeah, that was looking at both in like the support teams who are going to have to support these new tech coming in, but also in terms of users. As we get these more complicated bits of tech in, that means new users have a whole lot more hurdles to get through before they can use that system. So what key skills do we need to learn internally to support this with new things like FPGAs? And also what skills do we need our users to develop so that they can effectively use these new systems and not waste a lot of time once we've bought the shiny piece of kit?
Can I say we also have problems with old things like Fortran?
Maybe.
Yeah.
So I would say the answer will always be software. So learning the software you need to be able to take advantage of whatever technology turns up. Mostly the hardware, the infrastructure. It's a matter of just keeping it cold, putting enough electricity in it, trying not to let it fall over too often. Most of that's pretty boring, to be honest. The excitement is always in the software. So how do you learn the skills you're going to need to be able to run whatever code or version of programming language you're already using to be able to take full advantage of that? I mean, AI is not a technology, it's a piece of software. So how do you then sort of like, where are you positioned on that software roadmap? I wouldn't think about the hardware too much.
Yeah. Is anyone else going down the DevOps group route in their teams at all? Yeah, do you want to? Because I think that's an interesting thing around this. No? Okay, so certainly within, so we have an extremely large RSE group at UCL, and one of the things that we're doing, and part of this is some of the DevOps stuff, and actually, although we have our on-premise cloud, we're also doing an awful lot of work of upskilling the team, because we have this strategic partnership with AWS, in getting them through AWS exams as well. So we're kind of building that knowledge. We know it's coming, and we know that they're going to be swimming at us soon. So we're kind of very much trying to build that in the team with what little bits of downtime that we have. And is anyone else taking any kind of similar proactive steps or would like to? Yeah.
Hi, I'm Andrew from Southampton. One of the things that I did recently was I hired an application specialist into my team rather than, apparently I have to stand up. So we recently had a post vacant, and normally I'd be like, right, great, another software engineer, because that's what we hire. But because we've got all of these services and we want to try and provide more support and operations to them as well as just the development, I actually persuaded my management to let me hire in this application specialist. She's taken ownership of these services. She handles most of the tickets that come in, and if she's ever got a quiet day, it's her job to manage all of our documentation and FAQs and so on. And from an agile perspective, we've made her the product owner when we're doing any kind of new developments. So she's kind of the interface between our users and the engineers. And so far it's working really rather well, and I'm hoping to convince the powers that be to fund a second post.
Cool. Any other comments on that? At which point, I think there's an interesting question here around funders. And it's Peter's question, I'll get him to ask it. So I'm on the trustee of Stock RSE, and this is something that's come up in our discussions around how we fund RSE post long term. So kind of related to your question, so I'll let you ask your question. Yeah, you just use this one, and then we can have a chat.
This is a slightly loaded question, perhaps, but do you feel, as on the panel, that funders provide sufficient support for software, for data management, data people, and training to take advantage of this new infrastructure? That on Monday they said they were about to double the capacity of the current air systems, and if not, how can we, as DRI professionals, change that?
So I'm going to say, yeah, I think funders do, actually. And I think funders are very good at giving the right steer for strategy within organisations. And there's been a few calls recently and some funding proposals out for some very interesting training and skills development calls. So yeah, I think UKRI have listened. They understand the landscape, not just because we've got UKRI people in the room, I should say. So I actually think that UKRI are giving some very good steers. What I would say is that not every university is very good at taking the hint. Okay, and perhaps there aren't the internal conversations happening and the internal and external networking happening for every institution to be able to take advantage of what the funders are actually funding. Sometimes those UKRI strategy and framework documents can be a bit sort of nebulous to understand, and very few people in universities actually read them. But, you know, it's all there. It's laid out. It's very, very good, and it has been for years. But I think my comment is that, yes, they're good. Universities need to work out how to understand it.
So,
and I would say as well, talk to them. You know?
yeah, so I think some of this is what happens after that funding bit, that maintenance and that sustainability bit that maybe isn't initially included in traditionally in there. What happens then, I think, is probably the biggest question.
I would be quite optimistic that the announcement on Monday will have the funding you're looking for. There's a precedent in the exascale computing program in the US, which built a couple of the top 500 machines. They spent $4 billion, $4 billion, $2 billion on hardware and $2 billion on software. So I think it's not hard to see that people understand that they need to do it. Now, whether the UK government will take the hint, I don't know, but we definitely have precedents where people have put large amounts of money into the software development. Now, that isn't funded anymore. That program has now finished. So the software teams do have to kind of maintain themselves. But I think for about 5 years, there was a lot of money going into the software side. So.
Any other comments from the panel or the room? Okay, I think we have probably drawn a natural conclusion on our discussion, so I'd like to thank the panel.